Hello, and good afternoon, everybody, and welcome to CircuitStream's Introduction to HoloLens 2 workshop. I'm so excited to join you today, and I'm super excited to have my colleague Nikisa join me as well. Before I go any further, can someone in the chat please confirm, can you hear me? Can you see me? I can be heard and I can be seen. This is excellent news. Thank you for confirming, everybody. Much appreciated. A couple of housekeeping items before we advance with the content in today's workshop. First and foremost, to the right of the screen, you will see a chat tab. Clearly, some of you have already found it, but I do like to send this as a reminder to everybody as well. There's also a questions tab and a polls tab at the top of that window. If you do have questions throughout the workshop, please don't hesitate to paste those questions into the tab there. We will be doing an in-depth Q&A session at the end of Nikisa's portion of the presentation. We definitely want to make sure that we don't miss them, so please post them in there. We also do like to engage the audience by posting and pasting a few polls throughout the workshop. So periodically, I will remind everybody, please go to the polls tab and fill in the polls that we paste. Now, before we get going here, I am curious, for those of you located internationally, where are you all tuning in from today? I myself am in Toronto, Ontario, Canada, but we'd love to see our participants coming from all over the world. Hey, a couple of Canadians right away. I see Vancouver, Montreal, Calgary, international, there we go. Peru, England, Phoenix, great. I love seeing it. Thank you, everybody, for joining. This is actually the first time in my experience here at CircuitStream so far that we're doing a mid-afternoon workshop for us here in North America. There tend to be a lot of European folks who join us for these workshops, and we want to make it a little bit more of an appropriate time. With that said, today is a double header. So after our HoloLens 2 workshop today, we are going to be hosting another workshop on the XR Interaction Toolkit asset package led by a few of my other colleagues in just a few hours. If you haven't already checked out that one, I would recommend doing so. Without further ado, let's jump into today's content. My name is Kyle, and I am on the educational team here at CircuitStream. Before we dive into Nikisa's presentation, I'm going to take about 10 or 15 minutes here to introduce the company. At that point, my colleague Nikisa is going to take over and run you through a technical presentation on the HoloLens 2. That should last for probably 45 minutes to an hour, at which point I'll come back online to wrap things up and do a bit of a conclusion presentation. And then Nikisa will rejoin me and we will do that in-depth Q&A. So let's get into it. As previously mentioned, my name is Kyle and I'm on the educational team here at CircuitStream. I bring about 3 years of professional experience spanning across the sports and the technology experiences. I always love to tell this story at our webinars whenever I'm hosting them. You did read that correctly. I am, in fact, an NBA champion. I did have the opportunity to work here with the Toronto Raptors, and so I got to really take part with the championship run. No, I wasn't on the court. I'm about 2.5, 3, probably 10 feet too short to be a basketball player, but I was involved with the whole parade and everything else, so it was good fun. Joining me today is Nikisa. She is one of our lead instructors and developers here at CircuitStream. She brings a whole wealth of experience in the AR space specifically. She is a HoloLens and Magic Leap professional. I'll probably let her speak to this one more, but one of the facts that she likes to share about herself is that she was involved with a circus as well. So today we are going to be learning some circus tricks in addition to the HoloLens 2. Now, that's just a joke.
Yeah, the self-search is like right over there.
Yeah. So CircuitStream, who are we? This is a graphic that I love to share too. We are a very international company. We're a Canadian company headquartered in Calgary, Alberta. We were founded in 2015 when we noticed a gap in the personalized training and education space. To date, nearly 6 years later, we've trained almost over 30,000 students to help learn and manage XR creation. We're a team of about 20 experts coming from all different backgrounds to deliver education and training services. CircuitStream is a Unity certified training partner. And if you're not aware of what that means, training partners are approved by Unity based on their expertise, their focus on quality education, and their commitment to providing the highest level of training available. More recently, we've also become an official Unity channel partner to deliver training and application development services in the architecture, engineering, and construction spaces, as well as the automotive, transportation, and manufacturing markets. Anybody who does come through and complete any of our educational programs do get our certificate of completion as well. So definitely look out for that, and our training partnerships here will certainly be an asset. Now, we really focus on three things at CircuitStream, and education and training is the first, and it's sort of the main pillar of our business. Here are some of the organizations that we've had the pleasure of having in our programs over the past 6 years. As you can see, we've been able to work with companies like the US Navy, YouTube, Nike, the list goes on and on and on. And how do we actually do this? Well, we do this by delivering live and online training sessions like today. Beyond our free workshops and webinars like today, we do have a number of paid programs as well. And on the left here, the XR Development with Unity course. This is the program that started it all. It's definitely our flagship product or service within the education and training side of our business. I am going to speak more about this program later on this afternoon, but for now, just know that it includes 40 hours of live education taught over a 10-week period, and it covers the fundamental best practices of building VR and AR experience using Unity. Our next cohort commences on the 1st of December, and we are in the process of doing registration and enrollments for this course. So definitely don't hesitate to get in touch with us. On the right, you can also see our XR Project Accelerator course. This is a more recently launched program for those folks in the room here who don't need to learn the fundamentals of C# programming or the tool Unity itself. We've taken everything that we've learned about online education and created a project-driven program designed to help accelerate what you're already working on, while also having the opportunity to learn more advanced best practices delivered in the weekly labs. Another thing that I'm excited to announce today that is relatively new for us is a series of short courses that we like to offer. The first of which gets underway on November the 9th, and we're going to be covering the C# scripting fundamentals in Unity. This inaugural course is covering the fundamentals of programming with the C# language for the purposes of XR development. It includes 9 hours of total live and online education over that 3-week span. Now, one of the things that we feel differentiates our training and educational programs is the one-to-one support that's built into our programs. In both our 10 and our 8-week courses, every student gets dedicated appointments each week to work on their own personal project. The idea here is not only are we going to teach you everything that we think XR developers ought to know, but we'll work with you to bring your idea for a VR or AR application to life. This is Shay. I think you've seen Shay in the chat here already this afternoon. This is her personal project and one that she's super proud of. We really like to talk about networking and connecting members of our community with other like-minded individuals in the industry. We've always had a community Slack channel for the folks who've taken some of our paid programs, but more recently, pardon me, English is hard this afternoon. We recently launched a much more generalized community channel. And I'd like to take this opportunity to invite you all here to join. The link is on screen, but I'm also hoping that one of my colleagues behind the scenes can post it in the chat. Now, the second thing that we do and focus on here at CircuitStream is professional XR content creation. So we are a professional content creation agency, meaning that we can help you by building the training content that you'd like to bring back to your organization in XR. We'll consult with you to better understand your employee training as it exists today and to identify any barriers to success with the training as it exists. Finally, we'll work with your internal stakeholders to create an immersive experience that will meet and exceed your key performance goals in VR. So what are you interested in creating? I am going to toss a poll here. Are you interested in building an app for work or for professional use? Give me just a minute. I am going to paste this poll. So it's in there in the polls tab on the top right. Please have a look there really quick. We usually get a pretty even split, and it looks like today is no different. It looks like we've got about a 50-50 split at the moment. Alongside training and education and content creation, the CircuitStream platform is a cloud-based portal that we launched last year. It was designed to help organizations host and scale their XR content. Additionally, it allows organizations to easily track, measure, and analyze learning activities. But for now, enough about us. Let's talk about why you're all here today. So we teach most of our programs in Unity, which is a game engine that allows you to actually create the VR and AR content. But if you're brand new and you're just getting started in VR and in AR, what is Unity? I've already mentioned it a few times tonight, but Unity is a free 3D development engine for building games, simulations, and experiences. It is definitely the easiest way to begin making apps for XR, which, if you're not familiar with the term, is just an umbrella term for VR and AR and MR as well, which is mixed reality. Before we proceed, I'm going to toss in a quick poll here for the folks who are newer in the room. On a scale of 0 to 10, how experienced with Unity are you? 0 being you're brand new and you've never seen it before or heard of it before, and 10 meaning that you should be up on stage here with Nikisa and I teaching us how to use the HoloLens too. So just 1 second, I am going to post this, this poll here as well. Okay, there it is. Have a look. We're always curious to see what the skills in the room are currently like. Okay. Now, how does one actually go about creating their own VR or AR app in Unity? This is something I get asked all the time. Well, like anything, it starts with an idea. It all begins with that light bulb moment in your head. Next, you have to actually build that idea out in a program just like Unity. At that point, you can push your idea through what's called an SDK, which stands for a software developer kit. And then ultimately, once that experience has been rendered, it gets hosted on a device. In this case, of course, we're talking about the HoloLens 2. Now, there the HoloLens 2 is. It's a beautiful device. Today, obviously, that's what we're focusing on. But again, I'm going to toss another poll in here into the chat because I am really curious to know, which device do you own? So it's right here in the chat again. We'd always love to see. For those of you who aren't familiar, the HoloLens 2, what exactly is it? Because it's the other piece of the puzzle, really. Beyond the tool where you're building this content, the other piece of the puzzle is the device itself. So for now, before passing things off to Nikisa, I'm going to just go over some very, very basic details on the device. What is the HoloLens 2? Well, it's the second iteration of Microsoft's head-mounted AR device. It provides spatial and contextual understanding of our realities around us, and it enables new ways of interaction where we can integrate and work with the virtual universe. It provides more computing power, better sensors, longer battery, and more over its predecessor. So, without further ado, today is an intro to the HoloLens 2. At this point, I see that Nikisa is already here on stage, but I'd like to invite her to take over. I can't express how happy I am that Nikisa is taking over. She's an incredible developer and instructor, and also her puns are legendary. So maybe if we're lucky, today she'll bless us with a few of those. Okay, Nikisa, take it away.
Thanks, Kyle. Before we get started here, though, quick mic check. Thumbs up in the chat if you can hear me and you can see me. Or, hey, hello. It's great. How's your day going? I'm doing great. Cool. Awesome. Now, I saw earlier in the chat when people were stating where they were from, and I saw Rob, who's from Halifax, and I was like, yes, virtual high five. I'm from Halifax, too, near Hammonds Plains. So, yeah, great East Coaster. Nice. Cool. Well, before we get into the Unity part, I'll just share with you guys something that I've learned with the design of or designing for a mixed reality type headset, because it is a whole other world there. So the HoloLens 2, what we kind of have to understand, well, not kind of have to, we really do have to understand, is that the HoloLens is as much of an idea as it is a project. So when you're trying to make it work, you learn a lot of lessons about what it is, what its strengths and weaknesses are, and what makes it great. So what is the HoloLens really for, and how do you make something that is a great application for it? Like, how do you produce apps that have a really strong design so that the apps that you put eventually on the HoloLens device help it shine? So this section of the talk is really all about thinking about designing and developing for the HoloLens and what makes this product really stand out. So when we are thinking about the HoloLens, it's almost like building a plane as we're flying it, because the HoloLens is really a different beast. It is so different and so incredible and so remarkable. So if you think about when you're designing something for like a PC, Mac, we sort of understand their differences and their similarities. Like, they're both computers, even obviously computers, but they have different like interfaces and they have similar capabilities. But PC master race, just putting it out there. So they're familiar and they're pretty easy to understand. And if we think about like your Android and your iPhone, and we're developing that with Unity, those platforms are also very similar with minor differences. Like, they all have their sort of iterations of certain types of functions, like plane detection or face tracking or all of these things. So they're really just like reimagining different elements and then thinking about some very slight differences in those designs. So when you think about something like the iWatch or the Alexa, they're completely different animals. And they're new ways to think about designs. Like, what makes an Alexa good is different from what makes an iWatch good or a smartphone, you know? And then we have the HoloLens. Totally different than anything else that we have experienced right now. It is a new, innovative technology that we are experimenting with. Exactly like Pokemon. I want a pet that's constantly on fire. CRISPR. So if you think about the HoloLens, it has elements from different platforms that we've seen before, and you can really see those pieces in there in a lot of ways. But the HoloLens is just this revolutionary and far out device that sometimes we don't really understand its idiosyncrasies. Like head-mounted AR is still a new thing that we're still inventing and understanding. So we really need to like dig in to those differences. So those differences in designs, and by designs I mean like UI, UX, all those things. And how we think about that is we need to respect those differences first and foremost. If you don't respect those differences, you'll get lost in it. And it's because that we need to leverage those differences in the same reason, and that's what makes a HoloLens so great. It's because it's not a smartphone that you're holding up here. It's a head-mounted display, and you're not just using one hand, you're using both of these hands. So how do you design for both of these hands? Like, what do we do with our fingers? Jazz hands. But maybe not. That might not be the greatest design for UI and UX. Anyways, so we leverage these differences in the same way that there are differences in a smartwatch and an Alexa. And that's the goal that you really want to dig into when you are designing for a HoloLens app. That's where you get your biggest payoff. So, in a practical sense, when you are making an app for the HoloLens, first things first, you need to be using the device. There is no substitute. You need the device right here, and you need to be testing on it day after day, because from what I've learned, it's not like developing for a PC or a smartphone or anything like that. There are a lot of times where you can finish a design and be like, nope, does not work, scrap it, redo the whole thing. This makes zero sense. And that's just all part of the learning process. You have to be able to burn your bridges and then rebuild them anew. Almost like one of my favorite sayings is, we'll burn that bridge when we get to it, which is a metaphor if you don't know what that is. So you need to test on the device if you are designing for that HoloLens. Now, when so if anyone's sort of like tested or even worked on any sort of embedded device before, it can be a lot of pain, especially when you're on the cutting edge of technology, like the HoloLens. It can be a little rough sometimes. Like, why doesn't this compile? Or why is my sensor not being found? Or why doesn't this deploy to device? So you need to be able to iterate quickly and to spend a lot of time sort of fine tuning and tweaking in Unity. So you're not constantly building and deploying to the device, because that takes time, as we're going to see a little bit later on. And then next. So the HoloLens, this remarkable device, is all about its sensors. It's an amazing piece of technology as far as awareness of the world goes. And that's such a key piece of augmented reality, of AR, because AR is all about understanding the real world and overlaying computing on top of that. So the HoloLens 2 is really best of its class in that sense. So it's important to think about all the different types of sensors that the HoloLens has to offer. That's hand tracking, that's voice, that's eyes, that's a whole bunch of these different things and capabilities that you need to build around. Like, no other AR device has like the millimeter precision as the HoloLens in terms of location, what you're looking at, what the world is. You can measure where a table is to a millimeter degree of precision. You can measure where a door is, like your fridge door, knock on it, see if there's a salad dressing. So you can also have things like when this spatial awareness is sort of mapped out, is that you can spatially recognize all these different things. And you can use like VR or not VR, but like QR codes, like Vuforia does. And now you have these things that almost act like a VR handheld device type thing. Temporarily forgot what the word was for that. So you can do tangible things and physical things that smartphones can't really do. Like your iPhone has debatable. I will debate you. So the iPhone has things like depth perception and all that stuff, but it doesn't really understand the world in the same way that the HoloLens does. Like, you're not going to have a fully integrated experience that the full sensor sweep of this HoloLens provides you. So one of the first things that you have to design around with the HoloLens is its most impressive sensor, which is the hand tracking. So hands down, like best of its class, fully articulated hand tracking, which we'll see a little bit later on. And like where every single joint is in your hands to a very precise degree. So focusing on hand tracking is going to be a really key part in making a good HoloLens app. It's also one of the ways that this technology sort of differentiates itself from all other technology. Because even with a smartphone, as I mentioned before, you are holding the phone up with one hand and then gesturing with the other, and that's a different experience. That's a different sort of feeling. So as you're designing these apps, start with your hand interactions, and it is also that is a setting that you can do in your MRTK profiles, which we'll go over. So designing for hands is one of the most important things because, one, as humans, we have this neat little thing called proprioception. Proprioception is without looking where your sort of body parts are, you intuitively know where your hands are and what they are doing. So when you're designing for the HoloLens, you really want to focus on your hand tracking. It's the sort of dream come true when we can reach out and touch virtual constructs. So that being said, it is important to understand that the sensor suite also enables humans to use other things of communication. Like we can, or the HoloLens sort of enables humans to integrate their intentions and desires and their bodies into the computational world. It also means that it leaves a lot of people with the inability to integrate there. So by inability, we mean like it's an accessibility issue. Like my thumb is broken and I really should be wearing a brace, right? But circus in me is like, no. So it's an accessibility issue. Like what if I don't have two hands? What if I just have one? Or what if there's a astigmatism in one of my eyes and that makes my eyes not converge like most eyes do? So as technology gets more advanced and more capable of understanding ourselves and our bodies and our world, there are more exceptions to its ability to understand that. If the only way to interact with a computer is with a mouse, you can move this mouse with any body part. I can move it with my toe, or I can move it with, I don't know, maybe sensors that are hooked up to your pecs and use just electrical impulses. But this mouse is something that can be moved in different ways. I can substitute a mouse with like a joystick or an eye tracker and all these different ways that people can adapt themselves to computing. But with the increased sort of sensor fidelity on this headset, it's harder and harder for people to adapt themselves to computing. And computing needs to be more willing to adapt itself to people. So that might mean that maybe eventually I have this headset on and I have something in my hands and I can't use hand tracking. Like I am taking groceries out of the trunk of my car and I have like one screaming child that's vomiting everywhere and the other one is like a squirming wiener dog and they're just like fighting each other and battling to the death. And I'm there like, oh God, how do I close this? That could be a real life example of when your hands aren't free to use these things. So you want to use your voice. You want to use other sensors. You want to use your eyes, and you want to be able to cast rays and use air taps to interact with buttons. So this example has a tooltip that says that you can say adjust to also trigger this button. At the same time, you can use your finger to push it. So you have all of these robust sensors, and it's important to not rely on a single one of them for just one purpose. So you try to make your app as accessible and as diversely controlled as possible. So as AR devices become more mobile, we'll have more and more edge cases. So we will be moving away from people who are sitting at a desk and fully committed to operating a PC, and maybe you'll be driving, taking something, or something like that. And so your app has to be able to be controlled through a bunch of different ways. So users have a ton of different bandwidth to express themselves with the HoloLens. So it's up to you as a designer and developer to utilize all those expressions and to capture the attention of that user. In the same way that your human or your person can express themselves using bandwidth, your app needs to be able to express that bandwidth back. So every single one of these interactions that comes from a different sensor. It needs to express a different type of feedback to that user. So if you're selecting with your eyes, that feedback needs to be different from using your hands. So that is a different sound, that's a different animation, that's maybe a different color. So you need to confirm to your user that you understand the differences in sensors and inputs. They need some kind of feedback that lets the users, and it's almost like feedback overload. You need like animations and stuff like that, and maybe selection states. So you need to constantly be communicating with your user about what sensors they're picking. So eventually, everything that the device understands about the world, you need to confirm to the user that you understand that and that they can utilize this information. So it's doubly important now with new technology that reminds people of all these new capabilities, like when smartphones were just introduced and we were just learning how to swipe. We had to teach people how to swipe because this had never been encountered before. So in that same way, we need to teach people to use their bodies to interact with a different, wildly different type of computer interface. Making sense so far? Of course it is. You're all geniuses. Cool. Yeah, cool. So now we're going to get into some of the really neat stuff into the HoloLens 2. Wiener dog approved. Cool. So remember that the HoloLens 2 is a relatively low power computer. It has a mobile processor, it has low RAM, so it can't do a whole lot of things on board. And everything is draining the battery too. So you need to think about using something else that is powering its computing. So one of the ways that you can do that is through cloud computing, where you have your Microsoft Azure services. You know what I'm talking about. One of those things, and all of that rendering is done in the cloud, all that processing is done there, and then it's streamed to your headset, and you can render amazing, fantastic 3D models. Like maybe it is an architectural rendering of a building that is just being built at that site. You can throw on the headset. Maybe you'll move around all these things. Maybe you'll see that like one support column is not quite where it needs to be, in which case that design needs to be revised. And so one of the ways that you could use cloud rendering. Now, the other thing that's really neat is your maps integration. And by maps integration, I mean Bing. Bing me up, Scotty. Now, so what Bing is doing right now, it's part of the Microsoft suite, is it has a digital twin of basically the entire world. It's incredible what they've done. So if you are using your sort of maps integration, you can see this digital twin of where you are, and you'll see the sort of digital constructs of everything that is around you. So maybe you'll be able to see like the flights that's in the flight simulator of Microsoft, and you'll be able to see where those flights are in geolocation, which flights are overhead, like who's on this plane in the first place, like how much fuel does this thing have, where is it going. For personal reasons, you need all this information. Let's not go there. So that being said, we also have real-time translation and data service visualization. So this is your point cloud renderings, and you can just wrap it in a shader and send it to your headset and see maybe mining information that's underground. You'll see maybe pipes and maybe you'll see pipes that are underneath a building and everything like that. So this is the brief overview of designing for the HoloLens 2. So guess what we are going to do right now? This is my favorite part. We are going to do some Unity dev. And I'll show you guys how to get your apps up and running. And we'll start with the MRTK. Now, if you don't know what MRTK is, it's like the thing that has all these neat little packages that you can just drag and drop and add, and it gets your HoloLens up and running in Unity itself. So let's dive right in. I am going to open up a Unity project. Now, have no fear. This is, you don't have to follow along to the T if you don't have Unity or any sort of experience like that. Just a brief overview, and I'll show you guys all what to do. What we're going to do is we're going to create a bouncing ball that you can grab with your hands and throw, and it'll have collision detection and spatial awareness with your headset and all of that lovely, lovely stuff. And then after that, we'll have the Q&A portion of this, and you can ask all the absurd questions that you want. Like, why is the cloud blue? I have no idea. Why are clouds blue? They aren't blue. Are they blue? It can be blue. Thanks, iPhone 95. So let's dive right into it. I already have a Unity project up right here. You're probably correct, Eric. They appear blue. Revised, they appear blue. So I have a Unity project up right here. If you don't know how to do that, it's just opening up the Unity Hub and creating a project up here. And this is the one that I've created. blue everywhere else if it's this nice sunny sky. Anyways, so this is Unity. This is the Unity interface. We'll briefly go over it. We have the hierarchy, which is right over here. And the hierarchy just lists whatever is in the scene right now. And your scene is basically just, if you think of like lights, camera, action, it's what's happening in the world right now. And the scene view is where you're going to build your mixed reality world. Now, this world is going to be a little bit different because the world is already existing around you. This is a mixed reality headset. So we are going to do that. The first thing that you want to do is you want to get the MRTK package into your project itself. Now, to do that, you are going to go over to this site right here, and you're going to go to the MRTK, and you're going to download right here, and you're going to go to the GitHub repository, which is right about here, and it's in the MRTK release page right there. So if you're using a Unity version of 2019.4, you do not actually want to have a 2.5 package. I do recommend using 2.4, which is right around here. So this is what you're going to want to download. And you can just click on that and download all these things, which is right here. So the first thing that you want is your foundation. This is your foundation of your project and all those little packages that you're going to want. Now you can download either your examples or extensions. Your examples will have examples of like hand interactions and how to do those, maybe some UI stuff and some prefabs that are pretty nice, pretty nice. Now I already have these downloaded and it resides somewhere in my computer. It is right around here. So let's go ahead and import that package. We're going to go to Edit, or actually Assets, my bad. Go to Import Package and Custom Package. Now it is in my Passport, in my Downloads, and there it is. So I have both the examples and foundation. I'm going to import this foundation right there. So now there's this whole like generation debate, like millennials, Gen A. So what generation is Forrest Gump from? I'll tell you. I've already said it. Gen A. It's a great movie. Millenarial. So this might take a little bit of a long time. Yes, that is it. The releases at Microsoft Reality, Unity releases, that is. I had a trip planned to Europe later next year. And so I was thinking, it was to Finland. And I was thinking, like, Finland ships have barcodes on them. Like, why is that? Why do Finland ships have barcodes on them? And it's because when these ships come to port, they can Scandinavian. It's okay, you don't have to laugh. I can imagine it right now. So I have a little bit of a background in, actually not a little bit of a background. I have a background in Eric. The last time I said puns, we lost 15 people in the workshop. Immediately. So we have the project configurator, and this just applies some settings, and you're going to hit apply with the MRTK. And your settings, that's going to be in, once this is done. There we go. So this applies all the usual settings that you need in your Unity project. So that's going to be like your legacy XR or single pass instances and stuff like that. So you're going to want to apply all those things. When that is done, and you can also check to see if those have been applied when you go to Edit and your product settings right here. So we have VR supported right here, but we have a problem. You will notice that we are not in the correct build settings. We are actually building for something called a Windows Mixed Reality headset, which is right there. We have to switch that over, but we'll do that in just a moment right now. So we're going to go to our build settings. We're going to switch over to that thing. We can go to File and Build Settings. And when we are building something, we have to make sure that we have a scene to build. And currently we do not have anything here. So we're going to click on Add Open Scenes, and we have that bouncing ball. We're going to switch over to Universal Windows Platform. Now, the target device here is going to be your HoloLens. And the architecture type is going to be very, very important. Muy importante. You're not going to say x64. It's the ARM64 that we are going to build with. That is a very, very important step here, and we're just going to keep it like that. And then the next thing is we want a build type of 3D3. The other thing that you need to know is this minimum platform version. Now, this comes from a Windows SDK that you need to download on your computer before you actually get started with this thing. And that, my friends, is right about, let me pull up that. That little, here it is. Okay. Excuse me as I close my million tabs. So your Windows 10 SDK, this is where that platform type comes from. You need to download this and install it before you actually get started, else you're going to have a bad time. And that is what you're going to want to click, download, get it all done, out of the way. You also need to do a Visual Studio 2019 16.2 or higher. And of course, Windows 10. And I'll send this to you guys in the chat. Pronto. There you go. There is the link. The linky link, the sauce. And that's where that minimum platform version comes from. No problem at all. And there it is. So when we don't really need to build and run here because that doesn't really work. What we have to do is we actually have to either build the solution, which is what I'm going to be showing you guys. And in Visual Studio, we're going to be launching to the headset. There's a way to do this over Wi-Fi, and when you have the IP address of this thing, you can just connect those things and do all the magic. Now, this build configuration, I like to select debug because I get very nervous when things are just released. I'm like, no, it's not polished yet. It is not finished yet, but nothing is ever finished. So we have there, and then you can just switch platform to your Universal Windows platform. Now, when this happens, we're going to go back into our project settings and look at that virtual reality SDK. So I have a background in electrical engineering, and it's very math oriented, but I was thinking like, oh God, mathematicians have like a favorite tree, don't they? It's geometry. Bonus points if you can name the other tree. It's not coniferous. Yes, correct. 10 points for Gryffindor. Or Slytherin, who knows? So again, you click on apply, and then I'll show you guys what to do next to make sure that, hey, trigonometry. Are we twigs here? So now we need to check our build settings, or our project settings, sorry, and make sure that we have the SDK for the Windows Mixed Reality. And currently we do not. So it is very important to have your Windows Mixed Reality, else you won't be able to build onto your headset. So click that lovely plus icon and go to Windows Mixed Reality. There we go. Why, now I should be wearing glasses because my eyes are terrible, but why do students always wear glasses when they are doing math? It's to help with division. Anyways, so that's done. We have our Windows SDK. The next thing that we're going to do is we are going to get our scene set up to actually do the Windows mixed reality. Didn't see that coming. So now we're going to apply some scene settings to this bouncing ball thing. We're going to click on that Windows mixed reality thing right here, which should have popped up after you've imported your Windows mixed reality toolkit. Clicking on that, go to add to scene and configure right there. So the way that Windows mixed reality is set up for, you can actually use it for your Oculus Quest. It's cross-platform and it's wonderful, but there are two things that we need to understand here. We have the Windows Mixed Reality Toolkit, which has all of your profile configurations, and then your actual mixed reality play space here, which has your main camera, and your main camera is your headset. This is what it's going to use and to see the world in. So let's take a look at your Windows or your Mixed Reality Toolkit here. I'm going to move this game tab over so we can clearly see this right here. So if we are going to configure anything, we first need to clone, duplicate all of these configuration profiles. So if you want to fiddle around with hand tracking, you are going to fiddle around with your input right here, because we cannot edit any of these settings until we duplicate them. So you know what, let's go ahead and let's duplicate the first main configuration profile, which is right here, right at the top. Click on clone, and we'll give it a name. Let's do like HoloLens. Did I spell that? I did not spell that right. I am not known for my spelling as an English word. Let's do HoloLens 2 configuration profile. And click on clone. So that's going to create a custom profile for you. And all of the things that we clone here or in here will be saved in this folder, the Mixed Reality Toolkit generated profiles. So we are going to do the input because we really need, or actually, where are you? There it is. Okay, so we are going to do the input here. And we also need to clone this default mixed reality input system profile in order to edit all of these things. So click on clone here, and we'll rename this to HoloLens 2 input system, and click on clone. And now all of these things are set up for, well, not set up, but they are there for us to fiddle with. So first things first, let's go to, and now remember what I was talking about, all these sensors here. This is where you are going to handle all of those sensors and those capabilities and accessibility things with your app here. So we have your pointers, which includes like your gaze, your head gaze, your eyes, and like whatever happens there. And you have to control or clone that profile in order to do stuff. But the real main thing that we want to do is, where is that? Your hand tracking. So this is what we're going to use to interact with the bouncing ball that we're going to create a little bit later on. So we're going to click on clone and remove that. Let's do HoloLens 2 hand tracking profile and click on clone. And there we go. So right away, the first thing that you are going to want to look at is this hand mesh prefab, this articulated hand mesh prefab. Once it recognizes your hands, it's going to duplicate or instantiate this hand mesh, and it'll overlay over your hands itself. Now this is a default, and you can, if you're an artist, you can do your own shaders. Like maybe you want like Toon hands, because that would be cool. You know, channel your inner Breath of the Wild, which is like a really neat mixture of things. Anyway, so you can either turn off the hand mesh visualization, which is everything here, or you can turn it off by clicking nothing. And then you also have these joint visualizations here. That was not the chat, because I was hearing all the things. Yes, huge fan of Zelda. So we have this input system that we have cloned. Now, the next thing that we are going to do is we are going to clone the spatial awareness stuff. Now, your spatial awareness is how your device is going to recognize the world, how it sort of maps out your environment and all the things. So what we want to do is we want to enable a physics layer on this thing so that our digital ball or digital construct will be able to bounce off of these things and these planes in a really, really neat way. So we're going to first clone all of these profiles. We're going to click on clone here. Now, in order to have your spatial awareness here, you need two things. Not just your spatial awareness, but you also need something called a observer, a spatial observer. So your device, at the same time that it is mapping out your environment and sort of overlaying a series of triangles. And here's a trick question. Why is everything in the digital world made up of a series of triangles? If you look closely at a mesh, it is just comprised of triangles, 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 triangles. So who can answer that question? Why is it triangles and not something else? It's not a pun. But why? Why is it smoother? Deeper. Oh, Eric, you're so close. Eric B, you're so close. Varun, you are also so close. But go deeper. A little deeper. 3 points are needed to, so easy. Yes, Hasham, you need 3 points to define a plane. It is the simplest geometric shape that makes up other shapes. That is why. That was a trick question. You guys did well. I'm impressed. Well done. So we already have a spatial mesh observer. So because guess what your spatial mesh is comprised of? A series of triangles that are just overlaid onto your environment. So we have a spatial awareness system, which is your series of triangles. And then we also need to observe this thing in the same way that a particle is observed as a particle and a wave is observed as a wave. We have the spatial mesh observer that is observing the spatial awareness system. I feel like I'm repeating myself here. Anyway, so that's already been created for us. Now, what we can do is we can view some of these asset things. And let's see. So we have our spatial awareness, view asset, and it is right here. So let's take a look at this thing. Because there is yes, Cole's notes. So when we are looking at our spatial awareness, there is something that we can configure in your spatial mesh observer. Now, in order to fiddle with this thing, we also need to clone this spatial mesh observer profile. So click on clone, and we're just going to clone this again. We're going to get this into a muscle memory so that we can quickly get this up and running, because there is a physics layer that is muy importante. And click on clone. So if you take a look at the physics layer, it says layer 31 spatial awareness. You need this to happen, and you also need to check this because, things will be refreshing. So your physics layer is something that enables collisions with digital constructs that we are going to be fiddling with here. Now this is already checked, and sorry, the layer 31 is already there. It's there by default, and that's great. That's perfect. You can also have your own visible material. Now, right now, this is a wireframe material, so we can just click on that and see what that looks like. So this is going to be the material that's going to be shown when we map out our environment. Cool stuff. Cool. The next thing that we're going to do is, let's see. We can also teleport, and there's the input. And we have that hand tracking. Gestures are fine with the default. You can also clone that and fiddle with your manipulation gestures and your navigation. So your manipulation is your 2 hands, and your navigation is your 1 hand. 1 hand sort of like pinch. And so your descriptions here are a hold, navigation, manipulation, and a tap. Those are the main gestures that you can account for there. Now, before we move on and really get into creating the scene that we're going to have, for all of you Zelda fans, what have we learned from Nintendo? What is rule numero uno? Who should know this? That's gamers. Probably, yes. Jump. Rule number 1 that we have learned from all of our years of gaming: everything not saved will be lost. So save your scene. You see those little asterisks up there? That means the scene isn't saved and we have to save it. So quick and easy solution. Your shortcut is going to be Control S. Nintendo. So we have our toolkit, we have our play space. Now it's time to create the scene content. The first thing that we're going to create is we're going to create a prefab that is this ball. So I'm going to right click in the hierarchy, go to 3D object, and create a sphere. We can double click on that to focus on that, and we can hold our Alt and move around the scene in much the same way of like Maya or Blender or all that stuff. So this is a little boring because it's gray. Let's create a material, and I already have a material here. So this ball material, I'm going to drag that into the mesh render and drag that there. Now this ball material we're going to fiddle with here because that mixed reality toolkit has some shader standards. I'm going to click on this, and we have the mixed reality toolkit here. And let's do a standard shader for the mixed reality toolkit, because when you're designing for a mixed reality headset, you have to understand that not only is light coming from the headset itself, light is also coming from your environment. So the shaders on this thing are going to be different than your actual standard shaders on your typical virtual reality device or app or game. So Microsoft has, or the Mixed Reality Toolkit, MRTK, has the standard MRTK shader, and that is what we are going to use. And we see that it has changed a little slightly there. Now we're going to change the color a little bit by going into the albedo. Now bonus points if you can tell me what albedo actually means. It's Latin. I can almost hear you guys madly Googling from here. What is albedo? Albedo is a fancy term for light reflection. Yes, basically just, light reflection. So we're going to click into this little square right here, rectangle, and let's do a red. And you can do all these things. You can drag this around, but let's do red. Right there. Now I find these little shapes a little irritating. So you know what? Let's decrease these gizmos. There we go. We have a sphere. Eric B., you are on point today. You are on fire. So we have the sphere. Let's rename this to a ball. And now we are going to create a physics material for this thing. But before we do that, there's another rule that you should know about Unity, that in order for any physics to be applied to a digital object, or any Newtonian physics for all you nerds out there, it's something called a rigid body. Exactly, Varun. Now there's already a collider on this, so we need to add. Nice. So we're going to add a rigid body to this thing. Click on add component, add a rigid body, and the mass is 10, and that is fine. That is totally fine. And then we have the rigid body. Now we're going to create a physics material that allow this thing to bounce. So I'm going to right click in my materials folder, go to create, and right about here we have a physics material, and let's call this bouncy, like a bouncy castle. And over in the inspector tab, his last name starts with a B though, not a C. So we're going to increase this bounciness right here. And let's say a bounciness of 1 means that it would bounce forever. So let's not do that right now. Let's not have infinity and crash the device. Let's have a 0.8 right there. Now the friction combined, it's going to be an average, and then the bounce combined, basically just like how bouncy or how do you want this thing to sort of calculate its bounce. I'm going to click on maximum because I want the maximum of bounciness for a bounciness of 0.8. And so I've created my bouncy material. We will get into that a little bit later on. So the ball, I'm going to apply this bouncy physics material to my sphere collider right here in this material portion. I'm going to click and drag right there. And now we will get into the actual transform of this ball. So in the transform component right up here, the inspector tab basically just shows what is making up all the things of this ball, of this game object as it's called. Now right now it's a scale of 1, 1, and 1 in X, Y, and Z. So 1 we can think of to mean as 1 meter in real life. So if we were to put this ball onto the headset right now, the ball would be like massive. It would be 1 meter by 1 meter by 1 meter, or like, you know, all that volume stuff. So let's say that this is actually going to be something like 0.1. That sounds reasonable. That'll be like what, 10 centimeters? For all you Canadians, I'm sorry, Americans, you should just convert to metric. 0.1, 0.1, 0.1. And there is our ball. So we have a sphere collider, we have a rigid body, and all that lovely stuff. Now we're going to make this ball into a prefab. So maybe when we tap on a little table platform, that it'll spawn a new ball in case we lose it. And, you know, it rolls under something and we can't actually get it. So I'm going to have this ball, make it into a prefab, drag and drop into my prefabs folder. Boom, there we go. We have a ball. And now, since this is a prefab, I can actually delete this from the hierarchy, but I'm not going to do that just yet. Don't forget to save, Control-S, Nintendo. I'm going to create an empty game object that'll be an overarching parent for all the scene content, because maybe we want to anchor it somewhere. So you might want to have like a shared experience, you know, get some multiplayer in there. So I'm going to right click. We won't be going over that now. Don't fear. It's a little bit over our heads right now. That'll be for a different workshop. I'm going to create an empty. And this is an empty game object. I'm going to rename this as scene content. Right. So I'm going to drag this ball into scene content. And then, you know what? I'm going to move scene content into somewhere, a position that I know is going to be pretty nice once I put this headset on. And it's going to be 0.067, 0.171, and let's do 0.98. There we go. Now the ball itself, I'm going to move this ball let's do like 9 and then like negative 0.4. Now you don't have to worry about these things because I've done this a number of times, so you can just, do all that stuff. Now, we are going to create a platform for this thing. I'm going to right click, go to 3D object. I'm going to create a plane. Now this plane is going to be, I'm going to rename this to like a table. Table. You know what, let's capitalize that. And the scale will be something like 0.7. No, let's do 0.17. Something like that. And the y will be 0.0 that, and then z will be 0.01. Okay. Okay, let's move this down a little bit. Let's do negative 0.5, and then maybe negative 0.2. There we go. And maybe we'll scale that down a little bit more. So it looks like our ball will drop onto this table. Like so. And then you know what? Let's also give this a material. Right click, create a new material, and this will be the table material. And let's set this to the mixed reality toolkit, and let's do a standard, and let's give it a blue. Let's give it a nice blue, and you can drag and drop. Now I'm going over this pretty fast, but don't worry, you will have a recording, and you will also have a Git repository for this project, so you can clone it onto your desktop. Also, Nintendo, Control-S-Save. So we have the ball, we have the table. Now, there are other things that we need to add to this ball. I'm going to open up that prefab because this ball currently does not actually have the things we need to grab it, to manipulate it, to do all those lovely things. So I'm going to click on Add Component, and we are going to add an object manipulator script. Now this script comes from our MRTK profile, and this basically just allows an object to be movable, to be scalable or rotatable either with one hand or two. And then the next thing that we need on this thing is something called a near interaction grabbable. You can think of this thing as like a landing point for any sort of game object that has a collider that you want to be able to interact with using your hands. So we have those two things, and we have this. So what my preference is for an object that you are grabbing is to rotate not about the grab point. So let's say you grab it like right at the top there, like right at the top there, and it's rotating about that point there. And I don't really like that so much. It feels a little weird. I'm going to say it rotates around the object center there and there. And we're going to allow for far manipulation, meaning that you'll be standing far, you don't actually have to place your hand on top of this thing to actually manipulate it. Now we see the asterisk right there, so Nintendo Control-S. And now we see that the ball has been updated. This ball prefab has been updated here. Lovely stuff, like a lovely bunch of coconuts. Diddly-dee. So we have all of that stuff. And then you know what? Let's anchor this. Let's anchor this scene content. I'm going to add a component and add a world anchor. So it'll be in place for anything else that you want to do. So let's see. Control-S. Save. And you know what? I think we are just about ready. Oh, actually, you know what? Let's do a very simple script, because on this table, I want to be able to tap this table and spawn another object. So I'm going to add a component and add that object manipulator type thing. And so these are events right here. So we are going to create a super simple script that'll have a method that'll called when manipulation started. So the very first moment that you start to interact with this thing. I'm going to go into scenes, or not scenes, scripts. And I'm going to right click, go to create a C# script. And we're just going to say that this will be spawn ball. And double click to open that up. Eventually. Oh, okay. I was holding my breath there. I thought it was crashing. I built this PC for a reason, and the reason is not to crash. So we have a spawn ball script here, and we're going to do some stuff. We are just going to have, let's zoom in there so you guys can actually see what I'm typing. We're going to have a public game object. We can drag and drop in the inspector, and this will be the ball prefab, like so. And we don't need any of this nonsense, so void start, void update. And we're just going to have a public void called spawn ball prefab, like so. Now this script is going to be attached to the table itself, but you know what? Let's say, actually no. Well, nah, yeah, this will be fine. So what I'm going to do is I'm going to define a position in Unity where this thing is going to be spawned. Now positions in Unity are something called a vector 3 because we have an X, Y, and Z. How many components is that? 12. So let's define a vector 3 here, and this will be a position. And this will equal a new vector 3. And if this all looks like Latin or Pig Latin to you, have no fear. We do have introduction to C# programming course that we recommend before taking our intro to XR. It is super fun, super fun. Born of the masterminds of some developers and instructors here. So we have this, and this, since this will be on the table, this will be this.transform.position. And then .x. And I just want it to be like up a little bit in the Y direction. So I'm going to have a comma, and it's going to be this.transform.position.y. And let's say plus like, I don't know, 0.2 F for floating point. And the Z position would be this.transform.position.z. Now, if I make a spelling mistake, please do let me know, because I am not perfect. I am human. Now, you don't need to explicitly say this dot transform. It'll automatically assume that, but I like to be explicit. And then we're going to spawn the ball itself. We're going to say game object. Let's call this spawn ball, capital B ball, equal instantiate. And in parentheses, what are we instantiating? First, we are instantiating that ball prefab. Now, where is this position going to be? It's going to be position, that thing I just defined right above here. And now what rotation will it be? You know what? Let's just say 0 rotation. So quaternion dot 0. Or identity, sorry. There it is. And there we have it. We have a public method that will be called when we have when we tap or manipulate a table, this table thing that we have. So let's apply that to the table. Wait for it to compile. There it is, table. We have the object manipulator. We're going to add that script first. Add it here. And now that ball prefab, drag that right there. And now what we're going to do on this table is on manipulation started here. We're going to add that method to call. Clicking on add, we're going to drag that script from there to there. And the function / method. Now only in C# is a method and function the same thing. No other language. But we're going to say spawn ball that script that we have in spawn ball prefab. That is the method that we're going to call. So if all goes well, if I've remembered everything, let's check the build setting, or you know what, let's check the project settings again. And we have the XR settings, the VR is enabled, we have the Windows mixed reality there. And then let's check our build settings again. We have the HoloLens, we have the HoloLens ARM64, 3D3, we have the latest installed. Cool. Okay. Now is the moment of truth. Oh shoot, did I spell position wrong? Shoot. Position. Position? Is that wrong? Position? Am I going insane? Okay. Whew. Oh. Okay, cool. I mean, I could be going insane. Who knows? But we have that. Okay, cool. Okay, we are going to build and hold our breath. Everything looks ready to go. Click on build. And so here, I'm going to create a new folder called builds. And we're going to double click in there. We're going to select that folder and we're going to build it. Now this might take some time. If you hear any whining, that's because of my dog and he likes attention. Let's put this thing on. And of course it's off, or I have to redo my pin. Excuse me. Right there. All right, so now what I'm going to do is I'm going to use the Windows device portal so you guys will be able to see what I am doing on the headset itself. Let's see if that is still connected. Windows device portal, let's refresh that. Now this IP address right here, this is what you're going to find on your HoloLens settings. Now this is connecting via Wi-Fi. You can also connect by USB if you're using the Windows device portal. And so the views, the mixed reality capture, and what I'm going to do is there will be a live preview where you will see what I'm seeing on the headset, including all of the digital stuff. Let's see if this is building. It is not built yet. All right. Ah, there we go. So we have builds. I'm going to double click here. And now this is where things can get a little weird, a little squirrely, like Anna Kendrick, a squirrel girl. I'm going to right click on this thing and go to open with Visual Studio 2019. You know, one of the neat features of this HoloLens here is that we can actually flip this down, whoop, and flip it up again, in case you're using glasses. So we're going to go into some Visual Studio settings right here to actually launch onto the device. We're going to be in debug. Now this ARM, if you remember in your build settings, this isn't going to be ARM, it's going to be ARM 64, like Nintendo 64. Now it's not going to be a remote machine because I am connected by USB. You can do remote machine again if you are using your IP address of your HoloLens. So I'm going to click on that and go to device. Now, if all goes well, we'll actually be able to see this thing. I will be amazed if it actually works the first time. I'm going to debug, and we're going to start without debugging and pray to the demo gods. Here we go. So right now it is building onto the device itself. And let's expand that and see what it's doing. All right. Why do ghosts, because it's spooky season, why do ghosts like organic food so much? It's because it's supernatural. That's a good one. That's a real good one. I wouldn't say so. I have yet to verify that because you can build and run as long as you have a USB device selected. Okay, build started. All right, let's see. Oh goodness, let's see. Okay, let's see. Windows device. Oh, deployment errors. Interesting. Let's double check our build settings. So we have the Universal Windows Platform. And let's take a look. We have HoloLens. Yes, that is correct. We have the latest. It's installed. You can build and run on the USB device there, which is probably what you were going to do if you want to try that out. And let's see. Let's check our project configurations again. Oh, wait a minute. Did I add that? I did add that scene. Cool. Now, the next thing that we are going to do is we are going to look at the project settings. Edit, project settings, and let's take a look. We have for the Windows, we have, oh, I see. This is going to be 16-bit depth. And then we want to enable depth. And then we have the single passed instance right there. And then let's see, let's do, instead of the sky box, we'll do solid color. Don't forget to save. And then let's see. We have that table, and this ball right there. Table, spawn ball. Let's build it again. I'm gonna delete all this stuff. Oh, that's right, Visual Studio is open. Don't save, try again. And we will build it. Go into builds, select folder, and all that stuff. That might have been it. That might have been it, Chris. Good eye. But we have time for one more pun. What since we're on the topic of, spookiness, what has two butts and kills people? An assassin. That's one of my favorites too. Ooh, perfect. Let's open up that again, right click, open with Visual Studio. And of course, we're going to go to the ARM64 and let's do device, debug, start without debugging. I do need a laugh track. That is a brilliant idea. I'll get one of those Staples easy button, so whenever I push it, it'll be the laugh track. Taken directly from Friends. let's see. Hopefully I don't have any spelling mistakes. What do you call a dog that does magic tricks? Labracadabrador. What do you call an owl that does magic tricks? A pooftle. I like that answer. Hocus pocus. That's a good one. You know, for cat jokes, I was thinking about, because one of my friends got a new kitten and she was thinking about names, and I was like, how about Cleocatra? What about Catrick Swayze? Right? Why did the Can Crusher quit his job, Kyle? I'm so curious. So depressing. Huh. Here's a little bit of some observational humor here. Have you ever noticed that dragonflies don't actually walk? Their legs are just primarily. Oh, it succeeded! Ooh. Okay. Hold that thought. Okay. There we go. There was a Made with Unity splash screen that you missed. There it is. Oh, snap. Look at that. So we have our finger tracking here, that spatial mesh. So we can see that. And you know what? Let's allow all these permissions. Let's do yes. So let's first take a look at the hands. So you can see the hands, and remember the sensor suite that we were talking about in the precision millimeters. Like, look at this. Look at that. Ooh. Inch. Incredible. So the mesh that we see on our hands right now, that is your default mesh that comes with MRTK. Now, as an artist, you can create different shaders for everything here. We have this. So let's see. Let's see. And oh, there we go. Look at that. And then let's drop it. The bounciness should be probably a little bit more bouncy. And there we go. So we can see that I can enlarge it using that object manipulator script using two hands. And then let's see it. Roll off and bounce. There it is. Bouncing, bouncing, bouncing. So cool! I got excited there. Anyways, boom! There you have it. You can now create a bouncing ball on your HoloLens, pick it up, do all those lovely things. Right? Isn't it so cool and so wicked? And that concludes noise. Yes, Anthony, you will have a recording of this project. You've noticed here. I am a lover of disco. Anyways, so this is your bouncing ball project. Now, remember, you will have a GitHub repository link for this project and all of its ooey gooey goodness. And I will pass it off to you, Kyle.
Hello, everyone. I'm back. Thank you so much, Nikisa. Before we proceed, quick sound check. Everybody can see me. Everybody can hear me. All is good. Awesome. Cool. Thanks, guys. Okay, so let me just share my screen here once again. Okay. So thanks again, Nikisa. I really always love seeing what you cook up for these workshops. You really never fail to impress us. The puns are legendary as always too. I hope that everybody seemed to enjoy those. I had one good one. I spent it on the chat. I couldn't save it. So in any event, I can see that we've had some questions asked throughout the presentation, and I want to make sure that we can address them all in the Q&A session. Before we do proceed to the Q&A session, I want to take a few minutes here to wrap things up before we proceed. Also, I do know that we flew through the content this afternoon, so just as a reminder to everybody here, we will be sending out the recording of this workshop to go along with the 3D assets that were demonstrated as well via a GitHub repository. Before I proceed with the presentation, I am going to drop one last poll in here, so give me just a second to do that. Okay, so on a scale of 1 to 10, how likely would you be to recommend this workshop to a friend? Please take a moment to navigate over to the polls tab to answer this one for us. It's really, really important for us as we help to improve the free workshops and webinars that we offer, and to tell us whether or not we should continue doing content just like this. So please do take a minute to go through and do that. But in any event, let's carry on with the presentation. I really like this slide a lot here because I think it really speaks to the fact that if you've enjoyed learning more about developing for devices like the HoloLens 2, we'd love to have you join one of our programs, or to have your team join one of our programs. No matter who you are or what your current skill set is, we believe that we can help. Whether you're looking to change careers, start a business, bring this technology back to work, or train and upskill together as a team, we would be happy to connect with you to see if your goals align with the programs that we have to offer. Again, as a refresher, we are launching a new series of short courses covering various topics of XR development. The very first of these short programs is a short course covering the fundamentals of C# programming in Unity. The course starts on November the 9th and includes 9 hours of lessons over a 3-week span. The fee to enroll for that program is $199 US. We've also got our XR Development with Unity course, which again is the flagship program here at CircuitStream, designed to teach you how to build your own VR or AR experiences from scratch within Unity. Taught fully live, fully online, and includes 40 hours of education over the 10-week span. 10 hours worth of one-to-one appointments as well that I think are really important. You can use those however you'd like, but know that we would love to help you bring your very own project idea to life. The course tuition fee is $3,950, and the next cohort gets started on the 1st of December. Again, fundamentals, making your own app from scratch, 4 hours of class per week. That includes 3 hours of lessons plus 1 hour weekly appointments with instructors like Nikisa. And we definitely would love to help you build your own personal project. No experience is required for this course in particular. Same with the C# course. So beginners, please have no fear. We would love to help you out and have you join us. Again, if you're listening to me talk about our beginner-friendly 10-week course and you're thinking to yourself, hey Kyle, I'm already proficient in Unity and in C#, but I am so completely blown away by Nikisa's teaching skills, and I absolutely have to continue my learning with CircuitStream. Well, then first of all, we're very flattered and we should definitely chat after the webinar. But more importantly, second of all, we do have another program that may be a better fit for you. It's called the XR Project Accelerator. I spoke about it a little bit earlier in the presentation. But as a reminder, it's an 8-week course that has labs where you can continue your applied learning. But the star of the show here really is the amount of one-to-one support offered in the program. Each student gets 3 hours weekly, 3 hours worth of weekly one-to-one appointments where we can focus on you and what you're working on to help you bring your VR or AR experience to the next level. The course fee for this program is $44.50 USD, and the next cohort in this case gets started on the 5th of January. Now for both the 10 and the 8-week course, we do offer payment plans. So if you're considering enrolling into either of these programs, please feel free to take advantage of any of the payment plans listed here. One of the things that I haven't mentioned very much today is our team training offerings. If your organization is making a commitment to building VR and AR apps in the near future, and they'd like to send a few members of the team into our programs, we can definitely help there. We do have a catalog of 5 programs that we offer to teams that we can teach in a private session over an extended period of time. The interesting thing to note about our team training here is that we can be flexible on the content taught to meet your learning needs. In other words, we can create something custom if what we already offer doesn't align with your goals. Additionally, we can offer these training sessions in the Unreal Engine as well as in Unity. If you're interested in any of these educational programs that we offer here at CircuitStream, I'd highly recommend that you head over to our website to check out the learning page there to read more about our programs. I think a few of my colleagues in the back will drop a few links as well for you to check them out. Additionally, you're more than welcome to reach out to myself or to any of my colleagues here on the educational team. You've probably seen Steph and Vlad in the background answering questions and being active in the chat as well. The 3 of us together, we handle admissions for all of our projects. So feel free to shoot any of us a note if you want to get in contact with us. Connect with us on LinkedIn if that's your preferred method of communication as well. With all of that being said, let's invite Nikisa back on stage here to chat about the Q&A session. We'll go through any of the questions that weren't already answered in the chat by my colleagues on the backstage or in the questions tab as well. We do have about 20 minutes remaining, so if there are burning questions that you would like us to address, please feel free to paste them in there now. And we do also have the Slack workshop community as well, if you'd like to continue the conversation. So Nikisa, there you are. I'm going to stop sharing my screen. Let's go through some of these questions here. So is there anything that you guys see, sorry, Nikisa, that you specifically see that catches your eye? I'm just going through them here.
Let's see. Let's go right to the tippy top. Is the setup the same for WMR headset other than no hand tracking? Yes, I would say so. You need to go through importing the MRTK packages. Your hand tracking isn't going to be the same, but you will have to duplicate your profiles there and have those customized for whichever headset that you have there. Is it possible to create AR environments for use on the HTC Vive, which has a camera on it? That is a very good question. I can't say that I have experimented with that, but I would say that it would certainly be possible. And you should sign up for CircuitStream because I would totally help you on that. Anyways, can I use my GI Bill to play for? I don't know what that is.
I don't either. GI Bill. I was looking at that one earlier. Stephen, what I would say is connect with us afterwards offline, and we'll explore that together.
Okay, so follow up to Hashim's questions. There is a HoloLens 2 mixture of the toolkit configuration profile. Is a significant difference to the so you only want to clone these profiles when you want to fiddle with the settings itself. You can't fiddle with the default settings. You have to clone it first. So that's why it's cloned. And once you have that cloned, you can do all the settings from the inspector tab there.
I got one here, Nikisa. I pulled it up.
Okay.
First of all, Varun, you don't sound stupid. It's a good question. But can we use GPS and create a world-scale navigation system in AR using HoloLens? You talked about Bing Maps a little bit, but don't you have a story about airplanes and the like that answers this one?
Yes. So you can absolutely create a world-scale navigation system on AR using the HoloLens, and that's using your Microsoft services. So that's using your Maps integration, that's using your data visualization. Now, all those things you can use for creating whichever navigation or GPS information that you want to do. For example, you can use something that I mentioned earlier before. You can use both of these types of information to see the GPS coordinates of flights that are happening overhead with Bing's flight simulator that is also in conjunction using its digital twin. So that is absolutely not a stupid question. That is happening and we can do it.
Yeah, I love that story there. I imagine stepping out onto my balcony with the HoloLens 2 one day, looking up and seeing a plane and like knowing how many passengers are in it or something like that.
Yeah,
Creepy,
or
but
like
cool.
who's not on it?
Yeah, exactly.
Mm.
Exactly.
Oh, I see
What
one.
else do we
Here we
have
have,
here?
can any default configuration profile be used for both hand tracking and spatial awareness? These are two different profile configurations. You have to create new ones for every configuration that you want to do.
There you go. Here's one that referred to, we talked about a little bit. I'm going to start a live answer again. Why should we select 16-bit depth format instead of 24-bit in the XR set? What's the difference?
So that has to do with how color is represented in your HoloLens app or in your HoloLens device itself. It can only handle so much color because, again, it's having both your light coming from your environment and the light coming from the headset itself. So your blacks are never actually black. Your black isn't actually existing. Your black is actually just transparent.
The more you know. The more I certainly didn't know that. Okay, let's filter here. You can, Nikisa, you can filter by not answered as well. I don't know if that helps.
Oh.
Tab. Yeah, that's.
Oh, I see that. Okay. I know this is all based on developing in Unity, but I wanted to ask if anyone has ever tried Amazon Sumerian for developing on the HoloLens. Now, I have tried Amazon Sumerian. I have not tried it on the HoloLens. I've used it for some Rift applications and some Vive applications. I'm going to have to get back to you on this one because I'm not sure if Amazon Sumerian has HoloLens integration and capabilities like that. Currently, if you're using MRTK, that is either for Unity or Unreal, those two game engines.
There you go. I thought here's a good one. Device centric, not necessarily for the HoloLens 2, but creating AR environments for the Vive.
Yeah, I answered that.
Oh, you did. I'm so sorry. I'm just filtering through these questions here. What else? Oh, this is a good one. Here you go. How many feedback modes can be customized in the HoloLens 2 UI? For example, sound, text, haptics, etc.
So you can absolutely use haptics in controllers. If you have like an Xbox controller and it's hooked up there, you can also use like your Windows mixed reality controllers there too. You can also use, if you don't want to use like the onboard hand tracking, you can actually integrate your leap motion onto that as well. So your leap motion can also be connected to your PC. You can use hand tracking there. There's a lot of different animations that you can use for your UIs. In your HoloLens examples, in your mixed reality toolkit examples in the packages, it has a demo scene of interactions and hand menus and UIs and stuff like that that you can sort of poke and prod at.
Awesome. Yeah, super cool. I saw one here by Chris, more of a general, not so much of a question, just asking for your thoughts. We've sort of touched on this topic a little bit, but I think it's a good one.
Thoughts on VR's external camera technology to compete with Ad LiDAR could be interesting. I would argue that the hand tracking on the HoloLens is more sophisticated than that on the Quest. It feels it's much more articulated. It's much more accurate. I find that with the Quest, it actually provides like a little bit of lag. So I would say that the HoloLens has best in its class for hand tracking capabilities.
Yeah, absolutely. I'm totally in agreement.
Yeah.
On that topic, on the topic of gestures, iteration from from the second iteration from the first. Have you noticed any major differences between the devices?
That wasn't really what I was focusing on, but yes, there are differences. I would say that your like your air taps and your manipulation and your navigation, hold gestures, those are all much more fine-tuned and much more accurate. There is very little latency in recognizing these gestures and actually having them do something. I would say there's a pretty big improvement there.
Definitely. Yeah. When you were talking about the sensors, it was just, beyond computing power and battery power, just the sensors alone. Crazy differences here. Anything that catches your eye, Nikisa? There's a couple new ones.
Yes, I see. The futuristic one. It is a bit futuristic, but using 5G network bandwidth speed, can we leverage more AI capability features on HoloLens as 5G can overcome on the edge of the problem? So this is a very interesting question. And what I would say is that your 5G and AI capability features, I would actually move all of those algorithms and computing power to the cloud. That way, if your headset is connected to a 5G connection, you can stream things at a very quick rate. You can compute things at a very quick rate. And so all of your AI capabilities are going to be incredible. And the only thing that you would actually really do is see something rendered on your headset rather than your headset doing the computing itself. So yeah, absolutely.
It's a good question. Quick one here that I will address. Ulan asks, do we have an educational discount for colleges? So Ulan, we don't have any standing discounts for students or anything like that. However, we do offer group discounts. So when I was talking about private training, if you wanted to do some iteration of the 10-week course that we offer together, if a group of faculty from the college want to come together, then yes, we would offer a group discount, but not for the course as an individual. So I hope that helps. If you are interested and you do want to talk about this more, definitely chat with us offline though, and we can explore some options. Carissa's got a question here about texturing.
Okay.
So this one I'll leave for you, Nikisa.
Okay. Is it possible to make the 3D objects more solid on the HoloLens 2? They are more see-through on the headset, even though in the Unity editor it looks solid. Yes. So as I sort of said before, with the HoloLens and how it represents color, your lenses here, they are transparent. So most of your objects will have that sort of transparency effect, kind of like, ooh, spooky. But not quite. Now, there are some tricks that you can use, like you can use occlusion, you can use materials that are simulating a reflection of light to make things appear a little bit more solid than they are. But again, this is an AR headset. It's not, and this is only the second iteration too. So when we get to like the fourth or fifth, that's when things are really gonna get crazy. Which I'm super excited for. But right now, yeah. So as I said before, like your black colors aren't actually black; they're transparent. And based off of that information, you can sort of figure out what colors and what materials, what reflections are needed to make something a little bit more solid.
Absolutely. Okay, I think we have time for 2, maybe 3 more questions here. Just for everybody who's left in the room still, the recording stops after almost 2 hours. And so we're coming up on that time, and I want to make sure that the folks who weren't able to make it tonight have the opportunity to catch everything and not get cut off in the recording. So Nikisa, is there anything on your end that you see that I might have missed?
Let's see. The first one is stock rendering on the HoloLens 2 based on gaze. What do you mean by stock rendering? Do you mean like the universal render pipeline, or like standard pipeline, like scriptable pipeline? What do you mean by stock rendering?
Hopefully we can get a follow-up. Sri, if you're still here, definitely add that.
Yeah. That would be super cool. Well, let's take a look at, I'm just going to call you Ready. How does a low-code platform like Vuforia compare to Unity in terms of capabilities? Now, they both basically do the same thing. I guess it just depends on how your brain works and what you learn best doing. Like, are you a visual person? Are you a code person? In Unity, there are visual coding solutions if you are more geared towards that. They're basically just they're very similar, but you have a little bit more customizable abilities in terms of what you want to do in Unity and using game dev software that has a built-in physics engine.
Okay. I'm not sure if Sri is still here, so I don't know if we're going to get that follow-up question, unfortunately.
Cool.
Anything else here on your end, Nikisa, that you think might be interesting? Here's one on. Oh, sorry. Go ahead. You had.
Oh, I was just going to say that first question there by Severin.
That's the one I was going to say too. Awesome. I'll start the live answer.
Do you have experience using the AR Foundation Unity with the HoloLens? Now, I've experimented a little bit with it. Now, I wouldn't actually recommend using AR Foundation. I would recommend using MRTK. With MRTK, your eye tracking and your hand trackings are a little bit, they have a little bit more gusto rather than using AR Foundation.
Awesome. Looks like Sri pasted it in the chat as well. Universal pipeline, universal rendering pipeline.
Oh, what you cooking? Anyways, so the thing with the universal render pipeline is that it's really there for you to use artist tools like shader graph or visual effects graph. Now you can create and customize your shaders that way, taking into account of like the capabilities of how the headset renders things itself too. Those are all things that you have to consider when you're building your shaders itself. So it's certainly possible. Now you may run into some interesting things that might look a little bit strange. But as long as you know what you're doing and you follow some tutorials, the universal rendering pipeline, you can create some like pretty nifty shaders there, especially for the HoloLens. That'd be neat. Eric on our team here, he was on one of the teams in Microsoft that created the Hummingbird demo. And that Hummingbird uses some really, really neat shading and materials. And it's a way to teach people to use their hands to interact with things in the same way that we had to be taught to swipe on smartphones. And that's the thing that came from his crazy, insane brain.
Definitely. Yeah, that demo was super awesome. Okay, everyone, I think we're going to wrap it up here. We are coming up on that 2-hour mark. For the folks who are still here and have hung on right till the end, thank you very much for attending. For the folks who haven't yet checked out the recording, but will check out the recording from the past, we would love to see you all at our workshop later on this evening. We're doing one on the XR Interaction Toolkit. We've always got new live workshops and webinars like today's happening. So definitely keep up with our newsletter and check out our site. Certainly don't hesitate to connect with any of us here on the educational team if you want to talk about any of our programs. We don't bite. We will answer your questions. So, don't hesitate to reach out. But once again, thanks, Nikisa, for taking time out of your busy day to help us out today. It was lovely to have you with us as always. And thanks everyone so much for attending. Good night, good afternoon, good morning, wherever you are in the world. Thanks for tuning in and looking forward to seeing you at the next one. I guess.
And with a joke. Oh God. Okay. Hold on. Oh wait. Wait, I have one. Let's see. How do you solve any equation that you come across in the world?
I certainly don't know.
You multiply both sides by 0.
On that bombshell, we're going to end. Good night, guys.
See ya.
Bye-bye.